If I told you to walk forward 5 steps, you'll do it. That instruction has two parts. Forward, the direction, and 5 steps, the distance. That instruction is the vector. In Grasshopper, vectors are how we say move this shape 10 units to the right, or push this panel outward from the surface by half a meter, or every column shoots upward by the height we control with a slider. If you want to move geometry in Grasshopper, you need vectors. Day 3, let's go. Day 2, we made lines and circles. Now we are going to move them. But first, the most important distinction in 3D geometry, a point. A point is a location. It says I am here at coordinates 5, 3, 2. It doesn't move, it doesn't have a direction. It's just a position in space. A vector is a direction and a distance. It says go this way for this far. It doesn't say where to start from. It says which way to go and how far to go. The pin is a point. Fixed position, the arrow is the vector, direction and length. When you combine a point and a vector, you get a movement. Take this point, apply this vector, arrive at the new point. This is the move component. Take geometry, apply a vector, get a translated geometry.
Let's start with the simplest possible movement, moving a circle straight up. Start fresh canvas. Place a circle, right-click P input, set one plane, click at origin. Place a radius slider, value 3. Connect to R, you have a circle at the origin. Now place a number slider, height, range 0 to 20. Double-click canvas, search for unit Z, place it. Connect height slider to F input of unit Z. This gives you a vector pointing straight up, whose length equals whatever your height slider says. Now double-click canvas, search move, place it. Connect the C output of circle to G input of move. Connect the output of unit Z to T input of move. Look at Rhino, the circle has jumped up. Drag the height slider, the circle moves up and down like an elevator. The vector says go up by exactly this many units. The move component applies that to a circle. That's a vertical move. Now let's go diagonal. For diagonal movement, we use Vector XYZ. This lets us build a vector from 3 number components, like building a custom arrow that points in any 3D direction. Double-click canvas, search Vector XYZ, place it. Place 3 sliders Vx, Vy, Vz, range -20 to +20 for all 3. Connect Vx to X input, Vy to Y input, Vz to Z input of vector XYZ. Now place another move component. Connect the C output of your circle to G input of new move. Connect the V output of vector XYZ to T input. Experiment with Vx, Vy, Vz sliders. The circle moves in any direction. Vx 10, Vy 0, Vz 0. Circle moves right. Vx 5, Vy 5, Vz 0. Circle moves diagonally across the floor. Vx 0, Vy 0, Vz 8. Circle moves straight up, same as unit Z. Vx 3, Vy 3, Vz 6. Truly 3D diagonal movement. The vectors XYZ components describe the direction. The overall length of the vector is the distance traveled. One more useful component, amplitude. This lets you set the length of the vector independently from its direction. Say you have built a diagonal vector with Vx1, Vy1, Vz0. It points diagonally at 45 degrees. But you want to control how far the geometry moves along that diagonal. Place an amplitude component, search amplitude. Connect the vector XYZ output to V input of amplitude. Place a slider, move distance, range 0 to 30 to A input. Use the amplitude output as the T input for your move component. Now, the direction is set by Vx or Vy or Vz. The distance is set by move distance. 2 separate controls, 2 separate sliders. This is a common professional workflow for architecture. Define a direction, then control how far to move in that direction independently. Practice exercise 4 circles. Create a single base circle at the origin, radius 4. Use unit X with slider to move to copy 1, moving 10 units to the right. Use unit Y with sliders to move to copy 2, moving 10 units forward. Use unit Z with slider to move to copy 3, moving 8 units up. You should have original circle at origin, one right, one forward, and one up. All 4 circles from one base circle. 3 move component, 3 directional vectors. This is the beginning of array thinking.
That's all for day 3. You now know the difference between a point and a vector. You can use unit x, unit y, unit z for simple directional moves. You can use vector XYZ for any diagonal direction, and amplitude lets you control vector length independently. Tomorrow is day 4. We are doing scale and rotate, the other two fundamental transformations. We are also going to talk about why order matters when you apply transformations. And this is something a lot of architects miss until they made a mistakes themselves. Subscribe, hit a bell, and I'll see you in the day 4.